Okay, well this evening, sorry I don't have any guest teachers, but I do have a picture of something that Dalton and Austin came into my room one break, and they managed to take every cup in the room and set up this really cool pyramid without knocking it down, and luckily we were able to capture this picture on the iPad. So expect a question about this on your daily quiz. And so these are sixth graders, Dalton and Austin, and their tower of cups. And they're introducing today lesson 3.2, which is estimating with multiplication division, and actually a problem like this on a larger scale. How many cups would we have might make a really good estimation problem, but really it's just a fun picture for now. I probably could have wrapped this lesson into the lesson from yesterday, but with fall break coming up, I kind of wanted to wind down tomorrow anyway. So what we're going to do is we're going to talk about estimation techniques that we can use with multiplication division. And as we said in the video from the previous lesson, we can still use rounding. There's nothing at all wrong with just using plain old regular rounding. Usually we round to either the nearest whole number or the nearest 10. Now, one rule we usually apply, and there are exceptions always to just about any rule, but usually if the two numbers are reasonably close together, we usually round them both to the same place. So it wouldn't make sense to round one number to the nearest 100 and round the other number to the nearest whole number. Okay. If the numbers are far apart, there are exceptions to that rule. But anyway, so let's go ahead and just practice a little bit of old-fashioned rounding as is used in multiplication division. So let me give you an example problem of 4.72 times 1.8. And this is pretty clear what we're going to do here. By the way, just because this is estimating, we still show our work. So 4.72, if we round both of these numbers to the nearest whole number, this will round pretty easily to 5. We look at the 4, we look at the 7. 5 or above, give it a shove, so it goes up to 5. Same thing happens to the 1.8, it's going to move up to 2, and 5 times 2 is approximately equal to 10. So that is my estimate. This entire process is the estimate. We show the work, what the two numbers rounded to, and then this number here, the answer, is actually the estimate. So if I said to first round these numbers and then find the sum, difference, product, quotient, basically to find the estimate, it is finding this answer 10. Now let's try another one. 8.25 times 19.8. Again, one that if I round to the nearest whole number, this is going to make this much easier. 8.25 will round to 8, and 19.8 will round to 20, and 8 times 20 is going to be about 160. Actually, it's exactly 160, but since we rounded these numbers in the first place, the actual sum is 160. And let's get in the habit of either circling or boxing our answers. It just makes your work, especially your class work, a lot more clear. It also makes it a lot easier for me to find answers on quizzes and tests. All right, so really quickly looking back over this, by the way, notice I did intentionally use the two different notations for multiplication, both the dot and the star. I also could have used parentheses around either the top or the bottom. So anyway, so good old-fashioned rounding, still an estimation technique when we're multiplying, or even to some extent dividing. Okay, but here's the cool thing. We've got one more. We had three estimation techniques in the last lesson. We had rounding, like we just talked about, for adding and subtracting. We had clustering, which only works when we're adding a bunch of numbers that are all pretty close together. So it's a cool trick. Doesn't work very much. And then front-end estimation, which is not such a cool trick. It's a lot of work, but it gives us a really accurate answer. And that's also only used for adding decimals. Okay, rounding, like we said in the previous lesson, is one of the more universal ones. But when we're multiplying and dividing, we have another technique we use a lot, and it's called compatible numbers. Okay, now what compatible numbers are? Let's think about what this word means with people. What does it mean for two people that can be compatible? Well, despite what a lot of online dating sites might want you to believe, telling whether or not two people are going to be compatible, whether they're as friends, roommates in college, or even in a dating situation, it's not an exact science. Compatible, you know, there are obvious things that make two people get along better, common interests, things like that. Well, the same thing is true with compatible numbers. This is a little more loosey-goosey than rounding. Rounding, as much as it's an estimation technique, has some very special rules. You know that when you're rounding, you look to the next place, the one to the right of where you're rounding, okay, to the right, and if it's 5 or above, you give it a shove. Your number goes up one, and then you just zero everything else out, or if it's a decimal, you just chop it off. Whereas if it's 4 or below, you let it go. very strict rule. Compatible numbers isn't like that. You get a lot of leeway to maybe move a little bit more than you normally would when you're rounding, but to go to numbers that are desirable, things that are going to make the math easy. So you have to kind of think ahead to the math. All right, so let's go ahead and take a look at this. A good example of using compatible numbers, 93.4 times 17.28. Well, if I just round like I did the previous examples and round these to the nearest whole number, I get 93 times 17. All right, that's a little easier. I don't have the decimals anymore, but I don't know what 93 times 17 is. And I've been doing math a really long time. Okay? Now, if I round a little bit more loosely, I can think, okay, what would make this multiplication a lot easier? Well, 93 isn't that far from 100. And 100 is one of the easiest numbers to multiply by in the whole world, right? We just move the decimal or we just add zeros. Now, since that one went up a lot, we went up a lot more than we normally would have by rounding. Even if we'd rounded to the nearest 10, 93.4 would have gone down to 90. So to get to 100, we had to kind of break a few rules. And since we went up with this number, since we're multiplying here, why don't we go down with the other number? So instead of 17.28 jumping to another number, how about we just go down to 17? And 100 times 17 will equal 1700. Now, you see what I did there? I didn't use specific rounding rules. I picked a nice, easy number that was pretty close to the 93.4, but it made my problem a lot easier. Now, here's another way I could have done this. Let's go the other direction. Suppose I do take the 93.4 and I round it to 90. Okay, that's a pretty easy number. It ends in a 0. Now let's do the opposite with the 17.28. Instead of going down, since the first number went down, let's let this one go up. Let's let it go up to 20. Because 20 is a lot easier to deal with. Again, it ends in a 0. 90 times 20, well, 9 times 2 is 18, and then you get a 0 from each, so you get 1800. Now notice, we're getting a lot of variation between our two estimates, but that's okay. We've at least got a good ballpark estimate. All right. Now I'm actually going to just kind of show you, if I actually take the actual product of 93.4 times 17.28, I don't have enough room on the screen, but the actual answer, just so you know, was 1,613.952. And so you can see these estimates are both pretty much in the ballpark. They're both a little bit high, but look at how much time we spent finding them. Okay, and if I made a mistake in this one and I put the decimal in the actual answer, I put the decimal in the wrong spot. Let's say I said it was 161.3952. Well, these estimates would say, no, wait a second. That's not even close to what we expected. The decimal has to go here or it's not going to work. Okay, so this is what estimates are really good for, and this is a great example of compatible numbers. Let's take a look at another example. And again, I'm sorry, this is going to be a little bit over top of, let's see if I can maybe clear this up a little bit. No, probably not. All right, so suppose you have 93.4. Let's take the exact same numbers. And again, apologies that we kind of ran over there. Let's see. And let's instead, this time, let's change it to a division problem. Okay, now, this does have a pretty special rule. When we do compatible numbers with a division problem, to be compatible, we want things to come out easily. So we are going to insist on a division problem that the numbers I pick are divisible by each other. We don't want any remainders. We don't want any fractions. The whole point is to play around with the numbers a little bit and make sure I pick things that are, in fact, divisible. All right. So for this problem, same numbers we had before, I'm going to start with the divisor. And I'm going to pick a nice, easy number that's close to 17.28. And obviously, that's going to be 20. Okay? Now, we want to make sure that this number rounds to something that is divisible by 20. I could go all the way down to 80. That would work. 80 divided by 20 would be 4. But that's pretty far. We're much closer to 100. And more importantly, since I rounded the second number up, in division, it's better if you round both numbers in the same direction. It's better if we round the first number up too. So 100 divided by 20 is equal to 5. Okay. Notice that this time I'm using compatible numbers. I'm using this kind of loosey-goosey, pick easy numbers that work, and I'm going to insist on picking numbers that are in fact divisible. Now this one is actually remarkably accurate. If I take 93.4 and I divide by 17.28, I actually get a quotient of 5.405. So my estimate here of 5 is off by less than a half. Okay, a half of a unit. So that's a very good, very accurate estimate. And it was very easy. By picking compatible numbers that are easy to work with, we're going to get quick estimates. They may not be super close, but they're going to be close enough to catch any mistakes that we make. And more importantly, it's only going to take a little bit of time, just a few seconds to, and especially if we write it down, a few seconds to make sure that we have something that will catch a mistake. All right, so that's the idea of compatible numbers. Now, theoretically, you could use compatible numbers for adding, subtracting. We just never do. Okay, and actually, there is a notion that's a little bit like clustering. We could use if we were multiplying a whole bunch of numbers together that all were pretty close, where we use exponents. But generally speaking, our two main estimation techniques are either rounding or using compatible numbers. So when we're adding, subtracting, we usually round. When we're multiplying, dividing, we usually use compatible numbers. Okay, the front-end estimation and the clustering are fun. They're interesting, but they're not very prevalent. We don't use them all the time. Okay, all right. So let's go ahead. Let's wrap this up. Let's just do a couple quick examples. And so I want you to go ahead and take these three examples. The first two, notice, are division. The third one is multiplication. Okay, and I'd like you to pause the video. And for each of these numbers, you don't have to write the original numbers down if you don't want to, but go ahead and write down the number that you're going to use. And obviously, we're going to be using compatible numbers here. So write down the numbers that you used for each of the numbers and then the answer you get. And as soon as you're done, go ahead and resume the recording and see if you did the same thing I did. And remember, you might not have done the exact same thing I did, and that's okay as long as you get an answer that's pretty close. All right, so pause the video right now. Okay, well, welcome back. Hopefully with this first one, again, I always like to start with the divisor, and so 1.79 is pretty close to 2. So all I really have to do with the front number is pick an even number. So I could do 38 divided by 2 is 19. I had to think a little hard about that, though. How about if I just do 40 divided by 2? 40 divided by 2 is easy. It's 20. And that is going to be a perfectly fine estimate. Again, you might have been a little bit more precise, but it is very much important and imperative that the two numbers you pick, if you didn't pick 40 and 2, if you pick 38 and 2 or something like that, make sure you pick two numbers that are evenly divisible. Okay? All right, the next example, 82.54 divided by 4.25. Again, I'm going to start with the divisor, so that's about 4. And so why don't we round this to 80? And again, 80 divided by 4 is also equal to 20. Pretty easy. And the last one is a multiplication problem. I do have a negative number, so this one's kind of ugly. So let's start with that. Let's round that to -4. And the front number, I could probably round this to 35 times -4, or even easier, let's round to 40 times -4. And so that'll equal -160. If, on the other hand, if I had gone ahead and used let's use 37 times a -4. I've got to do a little bit more work on this. 7 times 4 is 28, carry a 2, and I got to remember that 2, and 4 and 3 is 12, plus the 2 is I get 148. I still get a negative. Very easy to make a mistake, so this is not as useful as an estimate because I'm just as likely to make a mistake doing it as I was the original problem. This was much easier, the 40 times -4, and that's what we're usually looking for when we do estimates. So look at all these numbers that I picked. Notice they're all pretty easy numbers. If I could, I tried to round to a multiple of 10. Those are easy numbers to multiply and divide with. That's the idea of compatible numbers. Okay? All right, well, that's it. And we'll practice. We'll wrap this up tomorrow in class, and that'll hopefully be a wrap before we go away for the fall weekend. Anyway, thanks for watching, and I'll see you in tomorrow in class. Goodbye.